Today, we're going to dig into a really big one. We're talking about a massive service disruption that basically took a huge chunk of the internet offline. It's a fascinating story that shows just how tangled up and interconnected everything is in our digital world. So, let's get into the anatomy of a cascading failure.
So picture this. It's late on a Saturday night. Everything seems normal. And then, without any warning at all, a fundamental piece of Amazon Web Services, a service that thousands upon thousands of companies depend on, it just disappears. It's gone. This wasn't some piece of hardware failing or power cord getting unplugged. No, it was something way more subtle and way more dangerous.
And this whole thing didn't happen in a flash. It was like watching a train wreck in slow motion, unfolding over almost 15 hours. It all kicked off with a database problem just before midnight. A few hours later, that cascaded into a huge computing failure. And from there, it turned into a massive networking crisis. It wasn't until the next afternoon that engineers finally got a handle on it. Let's trace this whole chain reaction right from the start.
Okay, so our investigation has to start with that very first domino to fall. And that was a critical database service called DynamoDB. Think of it as a foundational data store for countless applications. This is the epicenter. This is where the whole thing began. And to really get why it failed, we first need to talk about, of all things, the internet's address book.
That address book is called the Domain Name System, or DNS for short. You use it all day, every day, probably without even thinking about it. Every single time you type a website into your browser, DNS is the system that looks up that name and finds the actual numerical IP address for the server you're trying to reach. It's absolutely essential, and it works quietly in the background trillions of times a day.
So the big question is, what on earth could go so wrong with such a basic, fundamental system, right? How could the address for a service as gigantic as DynamoDB just vanish? Well, the answer is kind of wild. It all came down to a tiny, incredibly rare software bug.
And this bug has a name. It's called a race condition. Here's how it worked. Imagine you've got two automated systems trying to update the DNS records. One of these systems was running super slow, and it was hanging on to an old update plan. At the same time, a second, faster system came along, grabbed a brand new plan, and applied it perfectly. Then, being a tidy system, it looked around, saw the old plan was now obsolete, and deleted it. But, and here's the crazy part, right after it was deleted, that slow system finally woke up and tried to apply its old, now deleted plan. And the result? The system, trying to use a plan that no longer existed, essentially just erased the address for DynamoDB. For the entire US-EAST-1 region, which is one of the biggest internet hubs on the planet, a core service had just been completely wiped from the internet's phone book. Poof. So, with DynamoDB effectively invisible, the failure started to spread. This is where the next phase of the crisis begins, when the problem jumps from the database service over to EC2. That's the service that provides all the raw computing power in the cloud. See, normally, the system managing all the EC2 servers is constantly checking in with every single physical machine. It maintains what's called a lease, just to confirm that a server is healthy and ready to go. But here's the kicker. That whole lease system relied on DynamoDB to work. So when DynamoDB went dark, all those check-ins started failing. And all across the server fleet, these leases just started to expire. And this is where it gets really painful. When the engineers finally fixed DynamoDB's address, the EC2 management system woke up and suddenly saw hundreds of thousands of servers with expired leases. And every single part of the system tried to fix this all at once, creating this huge chaotic stampede of internal requests that completely overwhelmed itself. You know, there's actually a name for this phenomenon. It's called congestive collapse. A great way to think about it is like a citywide traffic jam, where every single car tries to race through the exact same intersection at the exact same time. The system was so busy trying to recover that it couldn't actually make any progress. It was total gridlock, and it meant no one could launch new servers. So at this point, the problem was way beyond being contained. You've got a core database offline, you've got the main compute service completely gridlocked, and now the ripple effect starts hitting dozens of other services that people use every single day. And the impact was just everywhere. Network load balancers started failing. Lambda, the serverless computing service, was throwing massive errors. Amazon Connect, which powers a ton of customer service call centers, started dropping calls left and right. People couldn't even log into the main AWS console to see what was going on. It was a complete system-wide breakdown. So, with the cloud pretty much on fire, how in the world did they put it out? Well, The recovery wasn't easy. It was this slow, careful, methodical process that took hours of really deliberate action from the engineers on call. Yeah, this wasn't just one single fix. First, the engineers had to manually restore the DynamoDB address. Then, to break that gridlock in EC2, they had to start throttling their own internal systems and selectively restarting parts of the management fleet. They even had to disable automated safety features on the network load balancers because they were actually making the problem worse. It was this delicate multi-front battle against a system that was basically fighting itself.
After almost 15 long hours, services were finally back to normal. But the job wasn't done. You could say the most important phase came next, digging in, learning from the failure, and making sure that this could never, ever happen again.
So what did they change? Well, first off, they slammed the door shut on that race condition bug and put in new guardrails so a DNS record could never be wiped out like that again. They also added something called velocity controls to network balancers, which basically stops them from making huge, rapid changes that could destabilize things. And maybe, most critically, they're building new ways to test for these exact kinds of massive fleet-wide recovery events so they can harden their systems against the very chaos of recovery itself.
You know, this whole event is just such a powerful reminder. The services we rely on every single day are built on these incredible layers of mind-boggling complexity. And while engineers are working around the clock to make them resilient, this outage really shows us that hidden deep inside all that complexity, there are other dominoes just waiting. And it leaves us all with a pretty critical question. What happens when the next one falls?